Today, I will talk about a real case. In July 2025, a 50-megawatt photovoltaic power station in Jiuguan, Gansu, the combiner box suddenly smoked and burned the entire array 3 minutes later. The accident investigation found that the theoretical short circuit current of the string is 120 amps, but the fuse was selected at 250 amps, which would not trip. The fault current of 160 amps. Contact resistance from normal 50 gradually increased to 12 ohm. The joule heat power soared from 1.3 watts to 30 watts. The temperature rapidly exceeded 200 degrees Celsius, which caused an arc. The DC arc has no zero crossing point, cannot extinguish naturally like an AC arc. The temperature is as high as 6,000 degrees Celsius. What's more terrifying is that the on-site investigation found that the fuse was an AC type. The arc quenching principle of AC fuses depends on the zero crossing of AC. Used in a DC circuit, the arc will continue to burn until the equipment is burned out. Eventually, the combiner box burned into an iron shell, and 56 surrounding photovoltaic modules were scrapped. The direct economic loss exceeded 900,000 yuan. This accident exposed to fatal technical errors. First, the rated current of the fuse. It should be selected 1.35 to 1 times of the string short circuit current. According to IEC 60269-6 GPV, the rated current should be between 83 and 88 amps, is about 1.45 times the rated current. If the short circuit current of the string is 120 amps, the rated breaking current of the fuse, not 250 amps. Second, DC circuits must use DC-specific fuses. Its arc extinguishing uses a multi-layer grid, forcing the arc to be elongated and filled with quartz sand to absorb arc energy to cut off the DC arc. If AC fuses are used in DC, will reduce the sectional capacity by more than 80%. The first step of correct preventive measures is calculate the expected short circuit current. Consider the IV characteristics of photovoltaic modules. Cable impedance temperature coefficient. The actual short circuit current is usually 1.1 to 1.2 times. Second, select the rated current of the fuse according to 1.4 times and close to the standard specifications. The third step is to confirm that the fuse meets DC 1500 volt GPV protection category and the breaking capacity is greater than or equal to the expected short circuit current at the installation point. Usually it needs to be greater than or equal to 20 kA. The fourth step is check the inside of the combiner box quarterly between any 2 points. Warning: if the temperature difference exceeds 20 C. If it exceeds 40 C, it must be stopped for maintenance. 3 key parameters for photovoltaic DC fuse selection. Rated voltage should be greater than or equal to the system's highest voltage. The protection category must be GPV. The sectional capacity must be greater than the expected short circuit current. When selecting according to IEC 60269-6 or GB or T and 31465 standards, the temperature reduction coefficient should also be noted. When the ambient temperature exceeds 40 C, the rated current needs to be multiplied by 0.9 or less. Use a thermal imager to inspect temperature differences quarterly. Exceeding 20 C is an early warning, according to the National Development and Reform Commission's criteria for determining hidden dangers of major electric accidents. Improper protection configuration on the DC side is a major accident hazard. The relevant person will face penalties. Do your photovoltaic fuses have GPD certification? Have you done a thermal imaging inspection? Let's talk in the comments section. If you have similar accidents, please submit them.